have you ever asked yourself why outdoor insulators they are not have this simple geometry where you will have one end fitting for the high voltage, a simple cylinder of insulator, and then at the other end you will have the conductor for the ground? Why we have to have those complex shapes for sheds and corrugations? If we have a closer look, for example, to this porcelain cabin bin, you'll see here those corrugations here, and also when you look here you'll see other corrugations for the glass insulators. So why we have these corrugations? And if you look here to the ceramic insulators as well, you will see here different shades, one large, one small, one large, one small. And when it comes to non-ceramic insulators, no exception to this. Look here, these are insulators, polymer insulators. These are, you can see here the sheds. Here are sheds. These sheds are straight line. If you look to those sheds, they come with an angle. If you look to this insulators, we have even something interesting. The sheds comes with an angle, and then there is one large, one smaller, a little bit smaller in diameter, and then one large, and so on and so on. And here you have even one large and two small, one large, two small to the end of the insulator. So why we have those different profiles of the insulators? This is what we're gonna answer in my lecture. So if these questions of interest to you, please join me to the explanation about the design of the outdoor insulators profile. And let's answer the question I just asked. Why we have those profiles? What is their objectives? Why we make the design or the profile of the insulators looks complicated? Why not to have just a straight line? Why we have those shapes in the outdoor insulators? Before we answer this question, we have to define important terminology, which is the leakage distance. What is the leakage distance? This is an IEEE definition. It is the sum of the shortest distance measured along the insulating surface between the conducting parts. So if you look to this insulator, this red line here, this distance, okay, is the leakage distance. When you look to the cab and bin insulators, this red distance is the leakage distance. The question is, do I want to have this leakage distance as high as possible or as low as possible? Think for a second. Definitely, I want to have it as large as possible. Why? Because large leakage distance, it will lead to what? Large surface resistance. Because as we know, in a very simple formula, R is equal to L, which is the distance, divided by conductivity times A. Okay, so we can say that R is proportional to the length. Okay, without going into the complications of how to find R for these geometries, but R is proportional to the length. So I want to increase R. Why? Because I want to reduce the current, the leakage current that will lead to flashover. So I want to increase R as much as I can. So to do that, we have two ways: either increase the length of a rod and become to an extent become not practical. Why? Because remember, those insulators, they have to carry high voltage lines, and they are in the streets and people are going beneath them. So the length of those insulators becomes extremely large. That becomes not practical. But this is an efficient way to increase the leakage distance and hence the surface resistance without increasing the total length of the insulator to an extent that is becomes dangerous. There is another thing also, that those complicated shapes will have here beneath and here also what we call a protected area. Protected area from what? From pollution. Because remember, to have a current on the surface of the insulators, you have to have a conductor pollution, you have to have wetting. So when you have those protected areas here, you are sort of protecting the insulator from being completely wetted. If I have just a rod, the rod becomes easily wetted. So even if you can maintain a long length of the rod, still there is another problem, which is the wetting of the insulator. So in brief, the objective of the profile design of the insulator to A, increase the surface resistance by increasing the length, B, increase the protected area, and these two together will work to what? To reduce the leakage current. Let's have a look to the ceramic insulators, how we do that, and the non-ceramic insulators, how we can do that. Now, for ceramic insulators, and thanks to the easiest or the easy way to make complicated shapes, because remember, we work with clay or glass. Those will be like in a liquid, so you can put them in a mold and you can get any shape that you want. So you can have those different profiles. The one I have shown to you in the lab is more of this type. So called the normal type, with the corrugation are not that big or large. However, if you notice the glass insulators, the grooves or the corrugations were deeper. And this depends on the severity of the pollution. How much protection, how much increase in the leakage distance I want to achieve. So you can see here different design. This is called a fog type, or for heavy contamination. So see here, those grooves are even much deeper than here for two reasons. We increase more the surface resistance, and we have more protected area, so that the when you have called fog type, we have heavy contamination. These areas will not be easily wetted, and hence it will be protected from the leakage current. This design, on the other hand, looks very simple. But this is an aerodynamic, and use that in the desert, so that we don't want to have accumulation of the sand. So we have this aerodynamic style, so that you will not have accumulation of the pollutant on the surface. Now, when it comes to non-ceramic insulators, we don't have this luxury of making complicated shapes, but we can do sheds like this. So usually those are injected in a mold, and then this mold will open and will take out the insulator. So we cannot have complicated shapes on those molds. So basically what we do, we can have those sheds, we can change the distance between them as such to achieve the leakage distance that we want. So here we increase the number of sheds, so we have more leakage distance, more surface resistance, and hence less leakage current. Also, we can see here the alternating design I have just showed you in the other video, one large, one small. Why is that? This is to avoid bridging between the shades when you have rain. So when you have rain, if the distance between the shades is large, then you will have no bridging, and hence there will be no flash over, because you could have a flash over because of the wetting. So we increase the distance between the shades. I can do it like this, but if you increase the distance between the shades like this one, you are reducing the leakage distance. So what we do, we insert sheds with a smaller diameter, so that we can still increase the surface or the leakage distance, but at the same time we avoid the problem of what? The problem of bridging during a heavy rain. So this is a very short summary about the importance of the insulator profile, why we are using complicated shapes when it comes to the design of outdoor insulators.